Welcome, ladies and gentlemen. This is Team 3, composed of David, Federico, and Yihang. Our project is ImproveWell Comments Analysis, and we are working with ImproveWell, a startup that created a platform where staff can directly inform managers of potential problems and suggest solutions. Our task is to take these messages and separate them into similar groups in order to aid the reviewing process by the managers. This functionality should be exposed over an API, allowing programmers to interface with our models. There are multiple ways to solve our task. One potential way to separate sentences would be to use IBM Watson's Natural Language Understanding API, and another solution is Microsoft's Text Analysis API. However, both of these solutions aren't specialized to the narrow field of analyzing medical comments that contain a lot of specialist language. For this reason, we started implementing different approaches to solve this topic modeling problem. Our first was the implementation of TF-IDF, the algorithm Google initially used for PageRank. The main outcome of this approach is the retrieval of the most relevant words within a document based on how many times they appear in the document, but also on their frequency in all the documents combined. Two more complex but similar solutions are that of latent semantic analysis, LSA, and latent Dirichlet allocation, LDA. These approaches assume that the words contained in a document are generated from a collection of topics, and they use statistical techniques to deduce which topics were used. Now, let's move to the architecture of our solution. We decided to choose Python as our main development language for several reasons. Firstly, it allows us to cut down development time thanks to its rapid prototyping capabilities. Then, it provides a wide variety of machine learning and natural language processing libraries, which make complex algorithms and models easier to implement. Another is portability, as it can be run on many machines, as well as being easy to pass on to another programmer compared to other languages. Our backend will be hosted on Azure, using a virtual machine. This contains a RESTful API, which is implemented using bottle.py, a Flask-like Python library, and our models based on NLTK and Jensen, two Python libraries used to implement our solutions. This backend will be duplicated for staging and for production on two separate virtual machines in order to catch errors before they reach our live production environment. To make our product available to non-technical users, we've implemented a front-end in React, which provides a way to interact with the API. This front-end is also served by the bottle.py backend. The main reason why we decided to use React as our front-end library is the possibility of building UIs by composing reusable components. This allows quick prototyping capabilities as well as a cleaner code base. In our Python code, we've strived to maintain the PEP 8 standard in order to make our code base easily understandable and maintainable by the client's developer team. An example of a non-technical user querying our application would be as follows. The user navigates to the website and submits a sentence together with the preferred model. For example, in our case, the user chooses the TF-IDF model and submits a suggestion gathered from the ImproveWell application. This makes a request to the corresponding API endpoint, which in turn queries the respective model and returns a JSON result. Our website then parses the JSON and renders the result accordingly. As we can see, we have managed to extract the main topics from the sentence. Could the staff get free access to coffee and tea, which are free, coffee, and access. When it comes to testing our solution, there are two main testable aspects. One of them are the models, and the other the API. To test the models, as the data is not labeled and it is a clustering problem, there's no effective quantitative way to test the accuracy of the models on real data. However, after these models are trained, we use them to predict a range of different phrases using different numbers of topics and words, and have users grade how well those phrases describe the original document. As for testing of the API, this can be split into two separate aspects, the first of which is correct functionality. To test this, we use Python's standard library unit test to make sure that the API behaves as expected in both standard conditions and edge cases. The second aspect is that of stress testing. These tests will involve an increasing number of requests per second until the system begins to time out requests due to overload. As we strive to maintain low latency and high throughput, we will be comparing the latency of all our models and recommending the one that performs best. As for costing, our proposed solution will just involve the cost of renting two virtual machines from Azure, both of which will be publicly hosted and include in their own storage. The cost of this setup is approximately £20 per month. In the future, this would likely be scaled up, and on most cloud computing services, this scale-up would be linear to the number of requests. However, as the pricing of ImproveWell would also scale up linearly with the number of its users, there's no effective cost offset. Future work will certainly involve further training of the models. This means that by feeding a large dataset to our models, they will learn to further generalize to new documents and improve their accuracy when identifying the most relevant topics. One of the potential risks with these models is that without enough data, their predictions are likely to be inaccurate and could in fact end up randomly mixing topics and being unreliable. It is essential to consider the fact that our proposed solution can be used in other contexts and is not limited to our initial problem statement, that being the separation of NHS employee feedback into topics. In fact, it would be quite trivial to create new instances of our models, which, by training on different datasets, could be specialized to solve a range of different problems. For example, they could be specialized on employees in a different profession, for example engineers, to learn to classify the data into specialized engineering topics.